Okay, number 6 says, on a standardized test, the distribution of scores is normal, and the mean score is 78. So let me draw that out real quick. So we have a normal distribution with the mean score being 78. So it says the standard deviation is 4, and they want to know if 700 students took the test, how many students would be expected to score between a 74 and an 86? Okay, so 74 would be 1 standard deviation below the mean. And then if we want to reach 86, we have to start numbering to the right. So 1 standard deviation above the mean would be 82, but we want to reach 86. So I'm going to go another standard deviation above the mean, and that's where I am. Okay, so if we want to figure out how many of the 700 students would be expected to occur in this range, well, what we have to do is we have to add up all the percentages in this range. So if you look at a normal distribution curve, you'll see that we're going to be adding up 15.1, 19, 19, 15.1, 9.2, and 4.4. And when you do that, you wind up getting 81.8% of the students scored in this interval range. So since there was 700 students, if we want to figure out what 81.8% of 700 is, you just take the decimal, move it over twice to the left, so it becomes 0.818. And when you multiply that out, you wind up with, well, to the nearest whole number, 573 students. Number 7 wants us to use our properties of exponents to determine what y is going to be equal to. Okay, so first thing we can do, when you have a power raised to another power, you just multiply those. So 8 times 1/3 would be 8 thirds. Okay, now in the denominator, let's think about our rule over here, right? Power over root. If you have x to the a over b power, this number in the numerator is going to be your power, and the number in your denominator is going to be the root. So again, power over root. So if we're looking at this right here, we can see this is our power, and this is our root. So we can write this as x to the 2/3 power. And I'm going to bring down the equals x to the y. Okay, now from here, if you're dividing two terms with the same base, you're just going to subtract these exponents. So 8 thirds minus 2 thirds would be 6 thirds. So we have x to the 6 thirds equals, and I'm going to bring down the x to the y. Now 6 thirds, 6 divided by 3 is just 2. So it's really going to be x to the 2nd power is equal to x to the y power. So that being said, now that our bases are the same, the exponents have to be equal. So 2 is equal to y, or y is equal to 2. All right, number 8 says, East-West Airlines has a good reputation for being on time. The probability that one of its flights will be on time is 0.91. If Mrs. Williams flies East-West for her next 5 flights, determine the probability that A, at least 4 of them will be on time. Okay, well, at least 4 means 4 or more. So in this case, we're going to have to find it for 4 or 5, because we're talking about a total of 5 flights. All right, so we're going to have to do the binomial probability formula for exactly 4 and for exactly 5. All right, so let's do exactly 4 first. So it's going to be 5C4, and then the probability her flight is on time is 0.91. So that means the probability it's not on time is 1 minus 0.91, which is 0.09. And to find our exponents with probability, whatever number is to the right of the C goes on your first parenthesis. So that's going to be a 4. And then to find the number that goes in the second parenthesis, just do 5 minus 4 to give you 1. Okay, we'll find that in a minute. Now we also have to write this out for exactly 5, so 5C5. The numbers in the parentheses are going to stay the same, but this time the exponent on our first parenthesis will be a 5, because again, that's the number to the right of the C. And then in our second parenthesis, it's going to be 5 minus 5, which is 0. All right, they do want your final answer to the nearest tenth. So, I mean, here you can write out, when you plug this in the calculator, even if you round it to the nearest hundredth, that's fine. But I'm going to just write out 4 decimal places. Although this is overkill, you don't have to write this many. And when you add these together, you wind up with 0.9326. So to the nearest tenth, it's 0.9, which means there's a 90% chance that at least 4 of them will be on time. Okay, part B, wants exactly 3 of them to be on time. So we're going to use the same formula, but this time, out of the 5 flights, we want exactly 3. So it'll be 5C3. There's still a 91% chance that it's on time, and a 9% chance that it's not. And this time, the number to the right of the C is 3, so that'll go in our first parenthesis. And then 5 minus 3 is 2. So when you plug this in your calculator, I wrote out 0.06104. They want it to the nearest tenth of a percent. So to change it to a percent, you're going to move the decimal place over twice. So that gives us 6.1% to the nearest tenth. Number 9 wants us to write the binomial expansion of this right here. Now, I mean, same thing like as in the last video. Normally on a piece of paper, I would write all the terms going across, but because the tablet's too small to do that on, I'm just going to write my terms going down, and then I'll write my final answer as one big long expression going across. Okay, so what we're going to do is we're going to start off, we always start off with whatever this exponent is, C0, so 4C0, and the next term is going to be 4C1, and then 4C2, and we're going to continue to do this up until we get up to 4C4, until the number before the C and the number after the C match up. Okay, then we're going to set up 2 sets of parentheses for each of these. In the first parenthesis, we're going to put whatever is in the first spot in our original binomial, and in the second parentheses, we're going to put whatever is in the second spot in the original binomial. So this 2x cubed is going to go in each of these first parentheses, and this negative y squared is going to go in each of the second parentheses. So now when you're putting the exponents on each of these parentheses, keep in mind it's the opposite of how probability works. With probability, whatever's to the right of the C goes on your first parenthesis. But with expansions, whatever number's to the right of the C expands out to that second parenthesis. So this is going to be a 0. This one's going to be a 1, and so on. So you could just number those, 0, 1, 2, 3, 4. Now to find the number that goes in the first parenthesis, you're just going to subtract the number before the C and the number after the C. So you're going to subtract 0 from 4. So 4 minus 0 is 4. 4 minus 1 is 3. 4 minus 2 is 2, 4 minus 3 is 1, and 4 minus 4 is 0. So now what you're going to do is you're going to go through and you're just going to figure out what each of these terms is equivalent to. So I like to just start off by doing all of my 4C0s through 4C4s. So 4C0 is equal to 1, 4C1 is equal to 4, 4C2 is equal to 6, 4C3 is 4, and 4C4 is 1. Then I like to go through and do just this first parenthesis next. So if we're going to do 2x cubed to the 4th, we have to do 2 to the 4th power as well as x cubed to the 4th power. So 2 to the 4th power is 16. And then here, when you're multiplying a power, when you're raising a power to another power, you just multiply these two numbers. So 3 times 4 is 12. So it'll be x to the 12th. So as I work my way down this list, I'm going to do 2 to the 3rd, which is 8. And then x cubed to the 3rd, well, 3 times 3 is 9, so it'll be x to the 9th. And I'm just going to do that all the way down. So 2x cubed squared would be 4x to the 6th. 2x cubed to the 1st, anything to the 1st is itself. And then 2x cubed to the 0 power, anything to the 0 power is 1. So now we just have to complete this column. All right, again, anything to the 0 power is just 1. Negative y squared to the 1st, anything to the 1st is just itself. Negative y squared squared, well, a negative to an even power is going to be positive, so it's going to be positive y, and then 2 times 2 is 4, so positive y to the 4th. A negative raised to an odd power is going to be negative, so this is going to be negative, and then y squared to the 3rd would be y to the 6th, so negative y to the 6th. And then the last one is going to be positive, because, again, our exponent is even, so positive y to the 8th. All right, so if we just want to write out our final expression now, if we multiply together these first terms right here, we get 16 x to the 12th. And when we multiply these out, we get negative 32 x to the 9th y squared. When we multiply our next set of terms right here, we're going to wind up with 24 x to the 6th y to the 4th. And just to keep going, the next set is going to wind up with negative 8x cubed y to the 6th, and then finally plus y to the 8th. Okay, and finally number 10. When an avocado is selected at random from those delivered to a food store, the probability that it is ripe is 0.21. So let's just draw a Venn diagram here. And it says the probability it is ripe is 0.21. And the probability that it is bruised is 0.16. And the probability that it is ripe and bruised is 0.0336. So that's going to go in the overlapping circle here. Okay, letter A says, what is the probability that an avocado is neither ripe nor bruised? Okay, well, in order to do that, I mean, there's one of two ways you can do it. I'm just going to go along with the way that's on the answer key. Okay, so what I did was I found the numbers that go here and here within the circles. So to find the number that goes here, you just subtract 0.0336 from 0.21, and when you do, you get 0.1764. And then you can subtract this overlapping value from the 0.16, and when you do that, you get 0.1264. And we know that whatever the four numbers that go here, 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 and then neither always add up to one whole. So what I'm going to do is I'm going to add up the three numbers in the circle. To give me 0.3364. And when I subtract that from one whole, whatever's left over here is going to be the neither. So the 0.6636, that's going to be our neither. So that's the answer for part A. Part B wants to know if they're independent, if the events ripe and bruised are independent. Well, we know that events are independent if the probability of ripe and bruised is equal to the probability of ripe times the probability of bruised. Now we know the probability of ripe and bruised is wherever the overlap in the circle is, right here. So that's going to be 0.0336. Now we know the probability of ripe is 0.21, and we know the probability of bruised is 0.16. So if we substitute those in to the right-hand side of the equation and multiply them together, we wind up getting 0.0336, which is actually what's on the left-hand side of the equation. So we could say that, yes, they are independent.